All right. Hi, everyone. All right. And all right. So looks like I'm the cold and coughing one today. So good morning from cold and coughing Sandeep Giri. All right. Okay. All right. Okay. Nani, can you drop me an email at support@CloudXLab? I would love to resolve it. And that's why I had sent an email earlier asking if we could solve it offline. Okay. Because maybe the password might need to reset if you're not able to log in only in Ambari. Okay. I see. I see. So you were out of city that could not check. No worries. No worries. Okay. So we'll fix it. But if you're not able to log in Ambari, you're not going to miss much. Okay. Are you able to log in Hue? All right. Then there's no problem. Okay. And console as well. Nani, are you able to log in into console? Okay, that we will look into. All right. Just drop me an email just after this session. I'll wait for some time and then we'll fix it. Okay. Wonderful. Wonderful. So, hi everyone. Hi everyone. How are you doing? How's it going for you? And all right. Sunny, please go ahead with your questions. Yes. So, okay, this question, thank you, Sunny, for the question. Okay. All right. So, yes, whenever we say memory, we generally mean RAM. Okay, random access memory. All right. So RAM and memory we will be using interchangeably. And disk and solid state drive, disk, hard disk, we are going to use interchangeably. Okay, although hard disk and solid state drive are two different things, but those we storage, disk, and drive. These three things we are going to use interchangeably. Memory and RAM we are going to use interchangeably. All right. Okay. Great. Great. All right. Any other questions before we go forward? Another question is, there will be inconsistency of data when there are more than one name node, but every name node will be having its own metadata. Then where is the problem? Okay. Okay. All right. So no worries, Ravi. It wasn't really expected. It is basically up to you when you want to finish it. But before certificate, make sure that you finish it. All right. Okay. So let me try to answer Sunny's question. Let me try to answer Sunny's question. If two name node. Imagine there are two name nodes and both are working together. Some users are going to one name node, other users are going to another name node. Okay. If one user has created a folder using one name node and other user at the same time trying to delete the same folder or trying to create a similar folder there in the other place. Now what would happen is there'll be collisions. There'll be inconsistencies caused by two writers. If there are two writers trying to write at the same place at the same time, this is what happens. Okay. If they don't write at the same place at the same time, if they write on two separate papers, those two papers become completely unreconcilable. Unreconcilable, meaning the two metadata changes cannot be reconciled. Okay, that is the problem with having two name node. All right. Or in other simple words, let's imagine there's a XYZ folder on both the metadatas. In one node, in one of the name node, they are creating a file inside that folder, and in another name node, it's trying to delete it. Now, which one will be considered if there are two name nodes? So that's where the inconsistency comes into play. Wonderful, wonderful. Okay. Yes, go ahead, please. Pradeep's question is it the left panel shows all the installed ecosystem in incorrect Cloudera? Okay. So actually we are using Hortonworks platform. Okay. So what we did was, instead of getting into this brand wars between Cloudera and Hortonworks, what we did was we first installed Hortonworks using Ambari, and then we took the remaining components, the components which were of use from Cloudera, and installed those. So we made sure that we have both the things from both the best of both worlds. All right. So what you see is actually mostly Hortonworks plus some part of Cloudera. Did I make sense, Pradeep? Was that your question? Good. So I'll be talking slow. That doesn't mean that I'm about to sleep. It's just that I'm having a little fever. I mean, since yesterday. So it's just very slight, so not a problem. And I'm having a little cold. So I'm trying to be a little nice to my throat. And yeah, this doesn't usually happen. It's just after 6 years this has happened. Okay. All right. So, okay, next question is from Sunny. Let's say the client is reading block 3 and the data node is trying to read. Let's say the client is reading block 3 and the data node is trying to read from is not responding. Okay, what happens next? Provided name node gives the client the list of data nodes. Okay, to pick the data from. All right. All right. So this is a very good, interesting question from Sunny. That does it retry or does it fail? That is the question. So the point is trying to make is, if client fails to read successfully a particular block from a file, will it try some other data node or will it give up? Okay, will it give error? All right. So yeah. So far, what I have understood from the library of the driver. So the driver is the one who is reading on behalf of the client, correct? The driver is the one who is reading on behalf of the client. And the way this driver is structured is the way it's built is if one block fails, it will try to read the replica of the same block, and it will try its best to do it. And there are certain retry counts. If that fails, then it would basically give up and move on. All right. So it's a very good question. Thank you, Sunny, for this. So yes. So did I make sense to you? So since name node will get all the three copies name node will give all the three copies upfront to the sorry. All right. So yeah. Okay, so the driver will be having the list of replicas, the name of replica, the data nodes containing the replicas of the block. So it is up to the driver to try it, and driver is designed to retry on some other copy of the data. Okay, so when the first time the client, okay, so here client slash driver, these are two different entities. Okay, here this is the client, this is the driver. Okay, or sometimes this is also called client driver. Okay, so this is the user, this is the driver library, and this is the name node. So name node generally hands over the detail and yeah. Okay, did I make sense now? All right. A question from Hung. A question from Hung. In reading and writing data, if one user is currently writing to the data for a particular file and another is accessing that file, would the user reading the file? Okay, so reader and writers are kind of, so very good question, Han. So question here is, will Hadoop let the user read the dirty? Okay, or how will it work? If one user is currently writing to the data for a particular file and another one is trying to read the file, would the user reading the file read the previous version of the file and not the updated version until the file is completed, writes to the data? File is completely written to the data. Okay, okay. So the good question. So let me rephrase the question. So what happens when there are one person reading the file, other person writing the file? What happens there? So the way it happens is the reader, let the reader finish, then it will start writing, and let the writer finish, then it will start reading. Although multiple readers can go together, but readers and writers cannot go together on a file. That's the strong consistency which HDFS guarantees. Okay, no two writers, no reader and writer, no reader and writer will go together. Okay, it's only two readers that can go together on name node, after name node actually. Sahida's question is, after writing data into data node, okay, if the client fails to inform name node but write is successful, how would name node get the updated info about the data node? Okay, so very good question. Again, let's say the driver went to the data node, wrote the data successfully, and then went back to the name node informing that went back to the name node but failed to inform name node. Okay, so client successfully wrote data to data node. Okay, client, this person went to the data node to write the data, and then it was supposed to go back to name node to inform that we are done, but it failed to do so. What would happen in this case? So the change that was done on the data node will be kind of garbage collected. It'll be kind of deleted after a point of time because it has not reflected at the name node label, and the end user would get an error saying unable to write data. Okay, yes. So yeah, it's kind of a rollback. Question from Srini: when a client writes a block of data to data node, after it is done, is it also responsible to let the name node know that write is complete? Is this how name node know the block is ready for replication? Yes. Okay. This is how it happens. Actually, there are two things actually. One, the driver informs the name node that I am done after writing to the data node. Driver informs name node that we are done writing the data. Afterwards, name node also cross checks with the data node. Okay. And as and when a block gets written, data nodes start replication between other data node and this one. Okay, that's how it happens. So a question from Srini, it's a good question again. When a data node fails, is it the responsibility of name node to create the replica of HDFS? Okay, or is it the responsibility of HDFS? So when a data node fails, whose responsibility it is to start replication? So if data node fails, name node will not get ping from data node, and therefore name node will assume that data node is down. This particular data node is down. Same time, it'll figure out that all the blocks which have lost due to this failure, where are those blocks on which machines? And accordingly, inform those machines to replicate, inform the two machines that can replicate between each other to start replication. Okay, so although the transfer of data happens between the data node while replicating the block, okay, while the transfer happens between the two data nodes, but the process initiation or the triggering happens through name node, because name node is the one who knows everything about all data nodes. Okay. So out of the two, so name node initiates the replication and data nodes do the actual data replication. Okay. And 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 therefore it is the responsibility of both name node as well as data node to complete the replication. Maybe that's the reason why it is we have written as HDFS. I would love to take a look at it again. Okay, I'll love to take a look at it again. I'll make a note of it. All right, whose responsibility to replicate? Check the quiz. Okay, I'm making a note of it. All right, good. Any other questions at this point? Okay, we have a question from RS. Extending the rollback is only applicable for that particular block or for the set of blocks in the logical unit. So when the data is divided into 3 blocks. So it is basically whatever we were trying to write on a particular data node. Okay, it applies for all of that. Okay, it applies for all of that. Okay, whether we were trying to write, so whatever fails actually, that is retried on another machine. Okay, all right, all right. Okay. I'm having a little cough. Okay, so any other questions at this point? All right. RS, was I able to answer your question? Okay. Okay. So, all right. Any other question at this point? All right. Let's move on. So, a quick review of what we have done so far. Okay. Okay. So, quick review of what we have done so far is one, we first understood why we are talking about big data, and we understood what does it mean by big data. And essentially, all it means to us that new kind of computing has started, whether it's parallel computing or distributed computing. Okay, why it's started? Because the CPU and the other resources were not sufficient enough. Therefore, it was important to either package multiple processors into one computer or divide the work amongst many computers. So these are the two things which have started to try to solve the problem of complex or big data problems. Now, there are many use cases of computing or big data in general. All right. And in the big data domain, the distributed computing domain, there are quite a few components that need to be covered, that need to be learned. And we discussed all of those in the first session. And in the last session, we talked about the most important component called Hadoop distributed file system. First, we established why the existing file systems do not suffice. So we try to take one example of storing 100 terabyte data. And we talked about hypothetical or the existing solutions to see if they have problems. So we try to understand what kind of problems traditional systems face and how do we solve it. We solve it using HDFS, and the idea was to have name node and data nodes. Name node to keep the metadata, which is what is where kind of information, and the actual data is stored in data node. All right. Then the file was not kept as such. It was cut into small pieces called blocks or chunks of 128 MB. Earlier, it used to be 64 MB, but now it's 128 MB and it's customizable. So there are many advantages of blocks, and every block is replicated on 3 machines. By default, you can change the replication factor per file. All right. Now, the transfer of the data does not happen via name node. It happens directly between the user and the data node, whether reading or writing the data. The driver consults name node about the locations of blocks and their replicas, and then the, the client, after gathering the information about blocks and the servers, the client talks to the data nodes, okay, directly. Any questions at this point? All right. A question from Sahida. Parallel writing is allowed in HDFS. My right understanding is correct. Yes, it is possible to do parallel block writing. Okay, meaning if you have 2 blocks to write, okay, so if you have 2 blocks to write, this client driver can write directly to 2 data nodes. Okay, can write directly to 2 data nodes. Yes, same client. Very good question, by the way. So this client driver can write parallelly to multiple data nodes. Okay, let's say you have a file which has 3 blocks and it needs to write to 3 blocks. So it can create 3 TCP connection to 3 data nodes parallelly and start writing data there. So a question from Pradeep, what are all the interaction that happen between name node and client only to get the list of name node? Yes. So primarily while reading the data, so I think I'll explain in this way. So this is one overview. So this is the library or the driver that is trying to create the file. So first it does is it informs name node that, hey, I'm going to create the data. Can you suggest the data nodes on which I can write? And also block the file name that I am going to write. So it will create kind of a lock on that file name and give a list of data nodes on which the driver should go and write to. Okay. As the driver goes to the data node to write it, the data node, after it has written successfully, will start replicating to other nodes. Okay. And right. And once it has successfully written one block, one machine successfully, it will inform the name node that it is done. It will inform the name node that it is done, and afterwards, the file will be considered as committed. So a question from Hung is there an upper limit to writing in parallel? So I'm not sure about upper limit, okay, because there would be some kind of condition on number of network connections, all right? There will be some kind of limitation on number of network connection. So I might have to take a look at it, all right? So Pradeep, did I answer your question? So one is for creating, then committing. Similarly, while reading, there's only one interaction to get the block location, and that's it. All right. So wait till what point we had covered in the last session? Did we cover this part? All right. So last time we covered that name node while keeps the entire metadata in the memory. And when we say memory, memory is random access memory, right? RAM is very, very fast, not even in reading, but also in writing. When you try to modify a variable's value, it's very fast. Okay, so updating an in-memory object is very, very easy as compared to writing to the disk. Writing to the disk involves converting a complex tree structured object. If you think about an object, right? An object is a complex tree kind of a structure, meaning there is a big object containing a variable that itself is another object, which contains something else, could be another object, and so on. So when you say, okay, ouch, looks like I was using my laptop's audio as I stood. Okay, is it okay now, Tamika? All right, is my voice clear to everyone? Just give me a second. Yeah. Okay, Alvin is hearing the echo. Okay, so why I don't. All right, do you hear an echo still? All right, all right. Okay, let me try to exit and join again. Will that be a good idea? Okay, let me just exit for a minute and join again.